And we'd just like you to know that you're at an astronomy station, and that, as you can see, is a circle. Mankind has been using linear geometry. John Horton Conway discovered the definition of a linear number. He generated the entire number tree, which is quite difficult to do because there are an infinity of infinities of pseudo numbers on the line. That is real. The line is something else. So the straight line is imaginary. It's imaginary. And when you have a right angle, making the triangle called the right angle triangle, you're dealing in fantasy that now defines general relativity and quantum entanglement. That came from the Greeks, and science is lost. It's lost its way. And so we're extremely far behind reality. We can't catch up now. I can. I'll show you how. That's the meaning of this special series. What Einstein would have given anything to have seen, I will show you. What Dirac struggled to formulate into some kind of coherent mathematics at the other end of the Einsteinian spectrum, the tiniest of all things. He invented hypercomplexity and failed and died miserable. Einstein, his contemporary, invented hypercalculus, and he failed and died frustrated. Quantum mechanics don't go together. So the second line down, as you will see over here, is quantum paradox. Science has been around for approximately 3 millennia. We have only used one number system, which I now have proved is totally inadequate. This is known, but it's not known directly. We're right on the verge of the greatest discovery of all time. Rudger Bošković of Croatia, a Jesuit priest at a time when the Jesuits were going out of style. This is the Bošković force curve in its simplest redaction. What you're looking at has extraordinary implication. What you're looking at here is the quantum transition between two states. This is an algebraic curve, which is therefore finite. This is the finite curve that explains the quantum in a way that you will directly perceive under my direction right now. What are the two dimensions of this diagram? Let me tell you so that you don't confuse yourself. There are two dimensions in a flat diagram called a planar diagram, which this is. This is a projection down from another higher space so that we can see it. What you see here is the quantum. It's exactly and only what the quantum is. So now you can see it. What is the quantum? This is the quantum. But you know now because of my very careful approach to this topic, a quantum has to be defined in a system. Therefore, the question that we need to answer in order to understand this diagram is, what is the system that is being graphed? It is the system of correlation in 2 dimensions of linear spatial separation, which is that dotted line, with the vertical, which is called the ordinate in Bošković's language. It's the y-axis dimension. What is that? It is, listen carefully, because this is the turning point. Literally, the turning point. This aspect, the horizontal aspect, is space. On the quantum of spatial separation. So you're looking partially at the quantum of linear spatial separation that is on the curve, on the blue line, which is curved. Yes, yes. So it's not linear, but this is linear. What is this? What is the ordinate? What is the other aspect in this 2-dimensional system that correlates linear spatial separation from this? What is this? It is the quantum of action, the quantum of energy. You're looking at the correlation between 2 quanta. This diagram is taken from Wikipedia on the nuclear force. And this diagram, according to Wikipedia, is the diagram of the strong force between 2 protons, between 2 spatial particles. Okay, so this is a diagram of the force relation between 2 space particles at their closest proximity. And you can see from this asymptote and from this asymptote over here that they are orthogonal. So the quantum of space is orthogonal to another quantum. What is the other quantum? You know what the definition of a quantum is, so you should be able to figure this out. It might take you some time. Take the time to figure out the correlation here shown between the quantum of spatial separation, which is only on this line, the linear spatial separation between 2 spheres. It's the linear correlation between 2 spherical surfaces. Intrinsic geometry. Your mathematicians are unacquainted completely with that intrinsic geometry of the sphere. I discovered it. So, to answer our most important question in the history of physics so far, what is the correlation between linear separation quantization And the vertical aspect, what is that? Do you know? Of course you don't, because your physicists don't know what the vertical aspect is. It's labeled over here as force in the fourth power of newtons. You can disregard that as simply identifying the metric. Well, what is the quantum of the metric of force? It's depicted directly on this diagram. So this is the orthogonal, actually conjugal, correlation between the two fundamental quanta in the whole universe is right here. And this is the curve of the binding energy between two protons at their closest proximity. The linear spatial separation between two protons when they are closest is this. This is how two protons correlate in force space. Force space is this. What is force? It's energy, explicitly composed as a force of energy, which you can see is two forces. There are two forces on this diagram. One of the forces has to do with gravity. The other force has to do with energy. And energy and gravity were thought to be incommensurable. They continue to be incommensurable, except on this diagram, they are fully commensurable on two infinities. Infinities. This curve going off in this direction, this way, that's linear spatial correlation. This aspect going asymptotically up is force correlation between two forces. Between two forces. Which forces? You could say attractive and repulsive, but that might confuse you with the Coulomb force of charge. This is not charge relationship, and Wikipedia states that. Then what is it? What is it correlating? What does this graph say? It says that as two protons get closer and closer together, what happens is, on a calculus inversion, this happens. And this is not spatial. This is spatial. The horizontal aspect, called the abscissa, is linear. This has been linearized, but it is not linear, and that means that neither force is linear. They're both non-linear. That's where physics ended until today. What is that? That is a circle. That is not a line. What that is the Bošković force curve. What is that? That is light from stars. That's the Pleiades star cluster, showing us that light has a transcendental quality that I will now show you so that you'll understand it and be able to teach to your children what is light. What is light? You're looking at it. That is light! What is that? It looks like that is also light, which is true enough, but you need to know more. And so I'm going to erase my face for a second to show you this is a composite image of several wave bands of light. What you're looking at is the birth of a galaxy. How does that have anything to do with quantum mechanics? Do you see a linear component there? Yes, you do. It's in the radio wave band. That is linear. And that means it's electrodynamic. If it's linear, it's electrodynamic. James Clerk Maxwell proved that. What is that? That is the perfect visual representation of electrodynamics, into which I will not delve right now, although I have in the past. Let me explain to you the meaning of this diagram. You're looking at everything that science knows about electromagnetism. Everything is right there, no more and no less. And there are 6 parts to this diagram, but they're in pairs on the vertical axis. So on the top axis, you see the relationship in the Coulomb force, known as electromagnetic charge, between positive and negative electrocharge. In the third to the right, on the top line, you'll see it's labeled B instead of E. Okay, that's profound, because the first two, showing centrifugal force and centripetal force of electrofield force, electroforce, is combined to describe magnetism, B. On the bottom one, you have electro, not electro, but magneto. On the top line is electroforce relationship with magnetism. On the bottom line, you have the magnetoforce relationship with electroforce. And the two parts of magnetoforce are inverse from electroforce. Centripetal and centrifugal combine in magnetism to generate electroforce to the same proportion that electrocentrifugal and electrocentripetal combine to make magnetoforce. So this describes very clearly the relationship between electroforce and magnetoforce in terms of two fundamental forces which are neither magnetic nor magneto nor electro nor electrical. They're this and this. This is centrifugal. This is centripetal. This is light. This is gravity. You're onto it. Stay with me. This is my most recent paper on the geometry of what I just showed you. The relationship between the two fundamental quanta, which are synonymous with the two fundamental Let's look. Let's be sure of our knowledge now. Let's make sure that we understand what we're seeing. There's that. What is that? That's where we began, and that's how we're going to continue. The direct visual representation between the two basic forces in the universe, centrifugal and centripetal, which define electrodynamics. is this and this in spherical space. Okay? This is the other public internet source of my documentation for the greatest discovery in the history of physics or mathematics based on a new geometry, which is the only geometry that the universe uses. It does not use human, Euclidean, Bronze Age, ancient, linear mathematics. What does the universe use if not human mathematics? It uses integral mathematics based on the sphere. And that's the end of this necessarily curtailed to 1 hour, which is already beyond the attention span of a typical American. You cannot possibly understand what I just said because it's not complicated enough. That's your fault. You now need to catch up with what is actual science. I know what it is, but your physicists don't. Your mathematicians are lost because they don't recognize that the linear system, mathematically, geometrically, or physically, Einsteinian, Diracian, or beyond, is hampered by an infinity at zero, which does not exist in spherical space. That's the most that I have time to relate to you. May Allah bless you with insight. May He help you in your pursuit of His wisdom. If you're not after that, there's no hope for you anyway. I hope you tune in. Thank you.